So here's a little more action with multiplying rational expressions. So our second example has got these expressions that are a little more intricate. So you're going to have to do a little bit of factoring. So we're going to follow the same process. Factor, cancel, multiply straight across. Imagine if you would multiply straight across right here as your first step, you would have to multiply this linear function by this linear function only to try to factor it again. That's nonsense. In this case, factoring makes a lot more sense first. So my quadratic at the top looks like it's going to factor to x minus 3 times x plus 2. All right. Divide it by 5 times x, that's a GCF, 5 times x plus 1. All right. And multiply that by 5 over x minus 3. Nothing is factorable about that one. And notice equivalent graphs, equivalent expressions. So I love doing my work on Desmos. I heart Desmos. Okay. And does anything cancel out? Well, I notice that I have 2 factors of x minus 3. Sure, this one doesn't have parentheses, but you know what? You can give it parentheses. It doesn't make a difference. So I can cancel out 2 factors of x minus 3. I also see that I have 2 factors of 5 that I could cancel out, which leaves me with x plus 2 as my only factor in my numerator over x plus 1. Let's see, x plus 1 is the only factor in the denominator. Equivalent graph? I think so. So that is my response. The last thing you want to watch out for is you want to specify any of these continuities before you cancel out anything. So this continuity is at -1 and at +3. All right. So that is another example. One more, real complex. Really, the only thing that makes this more complex is that I have more factoring to do. But again, factor, cancel, multiply straight across. Hopefully you're getting the point. X squared minus 16 is a difference of squares. So I'm going with x minus 4 times x plus 4. And I'm dividing that by x squared plus 8x plus 15, which factors to x plus 3 times x plus 5. And I am multiplying that by, well, x plus 3 over x plus 4 really has nothing for me to, nothing for me to factor right there. They're both binomials with a, man, I really messed up my parentheses. My parenthesis game right here is all messed up. All right. So let's see. I can divide that by x plus 4. Do I have equivalent graphs? Yes, I do. That means I factored correctly. I have, and you just want to be really careful when you're canceling x plus 3 and x plus 3. I got an x plus 4 and an x plus 4, which leaves me with an x minus 4 as my numerator, divided by, looks like I'll just have an x plus 5 denominator, and double check that. It is correct. That's the final answer. Again, look how little multiplication I actually did. Really, I factored and canceled, and everything took care of itself. So keep that in mind, especially with when you're actually multiplying fractions themselves. That, hey, I could factor this fraction first, and it would make my life a lot easier. So factor, cancel, multiply straight across if necessary. And that's basically what I've got for you. I hope that that was helpful. And I have nothing else to say really about multiplying. There is the issue of, well, what about dividing rational expressions? And all I'm going to say about that is if you're dividing, right, all I'm going to say, because I'm not going to do a separate lesson on that, is the only difference between A over B divided by C over D is one step. And that is that you go right back around and you turn it into a multiplication problem. So A over B divided by C over D is really A over B times D over C. That's it. That's it. After that, it becomes just like these problems. So when you divide, that is the only difference. You multiply by the reciprocal of the second function, and we're good. And I'm going to answer a phone call now. But anyway, happy learning. All right, and we are done. Hello.